Look closely at the IT infrastructure of a modern enterprise, and you won't see a single, unified machine. You will find a sprawling landscape of highly complex, but functionally isolated software systems and ongoing projects. Historically, we have treated enterprise architecture as a localized design blueprint, a specialized document created for one specific project, developed in a vacuum. When teams design these isolated pockets of technology, the technical consequences compound quickly. Different systems cannot communicate, operational velocity stalls, and the organization accumulates massive technical debt trying to patch the pieces together later. But the ultimate cost is felt at the business level. The overarching macro strategy of the organization becomes completely disconnected from the actual systems being built on the ground. When architecture is decoupled from strategic governance, a team can execute perfectly on a technical level, yet still contribute to a systemic failure for the enterprise. The international response to this widespread fragmentation is the ISO IEC IEEE 4220 standard, published in 2019. This standard does not dictate localized modeling notations, nor does it provide a new set of diagramming rules for engineers. This schematic visualizes its purpose, establishing a cybernetic control loop governing how information flows across an organization's strategic, management, and execution layers. We will deconstruct and rebuild this ecosystem layer by layer, revealing how it forces enterprise alignment. By treating architecture as a dynamic control system rather than a static document, organizations can systematically align ground-level engineering with the executive vision. The topmost layer of the ecosystem is architecture governance. Governance outputs two things: architecture collection objectives, which are macro-level business outcomes, and governance directives, forming strict compliance guardrails for the portfolio. Governance speaks in abstract strategic language. Directives like secure the enterprise are too vague for engineers to execute. That requires the next layer, architecture management, the critical translator. Management takes abstract instructions and converts them into highly specific, actionable management instructions. For example, governance might dictate a broad directive to ensure absolute data interoperability across all domains. Management then translates that directive into a specific technical requirement, such as mandating all models to strictly use internal JSON-based schemas. The management layer shields frontline engineers from strategic ambiguity, narrowing their technical problem space down to only those solutions that deliver clear business value. This brings us to the bottom of the ecosystem, the core processes of conceptualization, evaluation, and elaboration. Here, teams design alternative architectures, run performance simulations, and write detailed technical specifications. But a control loop goes both ways. What happens when these core teams hit a hard physical limitation, run out of resources, or discover a fatal flaw? As the work happens, the core processes constantly generate execution status data and send it flowing back up to the management layer. This upward flow is packed with raw metrics, simulation performance indicators, error rates, and technical bottleneck reports. Sending this granular execution data directly to the governance board would trigger massive information overload, paralyzing strategic decision-making. So management translates upward. It absorbs the raw data, abstracting it into refined strategic management status reports. Upon receiving this abstracted data, governance has clear visibility to pivot the macro strategy, reallocate resources, or soften initial directives if they prove technically impossible. This upward abstraction prevents executive blindness. It completes the cybernetic loop, allowing the organization to dynamically course-correct rather than blindly following a failing plan. Notice that the ecosystem we've built so far is strictly vertical. It is a straight hierarchy of top-down strategy and bottom-up execution. The final, most unique structural component of the ISO 42202 ecosystem is the architecture enablement process. Enablement is orthogonal. It doesn't issue orders or design systems. Instead, it acts as the infrastructure and central nervous system for all the other layers. Enablement deploys enterprise frameworks to governance, portfolio dashboards to management, and modeling software to core processes. But merely providing tools isn't enough. The technology landscape shifts rapidly, and the ecosystem's capabilities must adapt. This triggers the critical reverse horizontal flow, enablement requests, and feedback. Consider a core team tasked with building a modern microservices architecture. Their legacy modeling tools, designed for monolithic systems, will immediately fail them. The team formally requests new capabilities via this feedback loop. The enablement node acquires and deploys modern modeling tools directly back to the field. The enablement process pulls architecture practice out of a static methodology, turning the enterprise into a continuously evolving, self-upgrading learning organization. Looking at the fully realized ISO 4220 diagram, we can track three distinct information pipelines: the downward translation cascade, the upward cybernetic feedback loop, and the horizontal evolutionary loop. This system generates immense value, but it is deeply fragile. It relies entirely on these information flows remaining uncorrupted and unbroken. As management fails to translate directives into actionable instructions, the downward cascade stops. The core teams experience operational drift, building systems completely disconnected from the broader business strategy. If the upward execution feedback is severed, governance suffers from strategic blindness. The executive board remains entirely unaware of the technical debt mounting at the ground level until it is too late. Adopting this standard is not an exercise in drawing better diagrams. It requires an organization to relentlessly police the health and accuracy of these internal information pipelines. We operate in an era of hypercomplexity and rapid digital transformation. In a volatile environment, static, rigid plans and traditional waterfall architecture models are obsolete the moment they are deployed. Survival requires an architecture ecosystem that behaves like a living organism, one that senses operational friction, adapts its tools, and course corrects autonomously. Technical leaders must move beyond simply implementing frameworks on paper. They need to hardwire these exact information flows into their daily operational cadence. A perfectly aligned architecture ecosystem ensures one critical outcome. When the business strategy pivots, the enterprise's entire technology stack turns flawlessly in unison.